A union is similar to an intersect operation in that it combines the attribute information. The difference is that all features in the participating layers get included in the output. Earlier, when I was describing intersects, I used the example: if one wanted to know which areas in Redwood National Forest intersect with Humboldt County, the output for the intersect operation would be a layer composed of polygons where these two map layers overlapped. With a union, the resulting output layer would be made up of all polygons from both datasets. The output of a union operation will always be more extensive than any of the outputs. So here we have the erase overlay operation. You can kind of look at erase as an opposite of a clip. In an erase function, areas covered by the erase feature are cut off or erased from the input layer. Erasures may cut existing polygons apart, or where there are coincident lines in the two data layers, may preserve the edge of existing polygons. Let's look at a scenario where we would use the erase function. In this case study, we need to find the amount of legally grazable land after an ordinance is put into place. Humboldt County is considering the imposition of a new ordinance to prohibit cattle grazing within 100 meters of a stream. Cattle can present all sorts of problems in terms of erosion, degradation of stream quality, etc. So we want to know how much land will still be available for the cattle farmers. So we've already acquired our data. We've got our Humboldt County layer, we have our zoning layers within Humboldt County, and rivers that fall within Humboldt County as well. The next step would be to select by attribute all of the agricultural zones that are within that zoning layer, and then we will export that selection as a new layer. We then would want to apply a 100-meter buffer around the rivers layer. So here we could see that we have now a 100-meter buffer around those rivers. Finally, we want to remove portions of the agricultural land that fall within the buffer zone. So if we go into our ARC toolbox and then analysis tools and overlay, we will select the erase tool, and then we have our input feature of that agricultural zone, and we want to erase any of those river buffer polygons that fall within that ag zone. And again, you're going to be putting that output feature into your working folder, and you're going to tell ArcMap to go ahead and erase. And the resulting output layer is a feature layer containing only the legal grazing lands. So if you take a closer look at this side, those agricultural zones are now without that 100-meter buffer and without those rivers included. Okay, so now what if I wanted to sum up all the values in the acre field and get a total amount of legally grazable land from that output layer? By erasing out the agricultural land within the buffer zone, we've modified the size of these polygons. Though it has all the attributes, the geometry in the acre field needs to be updated. So if we're looking at the attribute table for the now approved grazing land, and then we look at the attribute table from the agricultural zoning layer, we can see here that the acre field is still reflecting the same number. So we will have to go ahead and update that geometry. So whenever you run an overlay operation that modifies the properties of area or length for a set of features, you have to update that area or length In ArcGIS, we would use the Calculate Geometry tool to accomplish this. And so this is not just with an erase tool. Again, it's with any overlay operation that you run that modifies the properties of that feature geometry. So to do this, you're going to right click on that attribute field. In this case, it's the acres, and it's going to bring up your little right click window, and you're going to select Calculate Geometry. And then you're going to, again, make sure that you have the correct field selected. And of course, you want to make sure it's in the correct coordinate system, which ArcMap should just automatically fill for you based on the coordinate zone of your layer. And then you want to make sure that your units are correct. In this case, it's acres, and then you'll go ahead and tell it okay. And so now when you compare the two attribute tables, you'll see that the acres in the grazing land has been updated, and of course it's smaller than that original agricultural zoning acres. So again, if necessary, you need to remember to update the geometry area or length after each overlay operation. So the next few slides are going to be mostly review, but it's important to remember when choosing how to display your data after you've created your outputs from various steps of operations. Data classification is used to simplify and understand numeric data. Through classification, it is possible to identify patterns and trends or to alter data by creating a subset of specific classes. Classification is mostly organizing data in groups. You can do this by creating a series of class intervals, which is a range of values that do not overlap. The value that defines the boundary between each class interval is called a class break. You can think about it as a series of buckets that the data gets sorted into. And so over here is a histogram, and a histogram is a graph of all of the individual values of data organized from smallest to largest and displaying the number of times each value occurs. A histogram makes it easier to examine data classification. The x-axis shows the data values, and the y-axis the number of times that value occurs in the data set. So here we have the equal interval classification method, and this divides the range of data values by the number of classes chosen. By doing so, it creates class intervals with equal ranges of values. In this graph here, the range of population values is from 0 to 8,188. There are 4 classification intervals. The equal interval method divides 8,188 by 4 to get 4 equal classification intervals, each with a range of 2,047. In a quantile classification, each class contains an equal number of features. A quantile classification is well suited to linearly distributed data. Quantile assigns the same number of data values to each class. There are no empty classes or classes with too few or too many values. Because features are grouped in equal numbers in each class using quantile classification, the resulting map can often be misleading. Similar features can be placed in adjacent classes, or features with widely different values can be put in the same class. You can minimize this distortion by increasing the number of classes. So here you can see in this graph, the range of population values is from 0 to 8,188, and there are 4 classification intervals, and each class has 669 features. With natural breaks classification, classes are based on natural groupings inherent in the data. Class breaks are identified by the best group with similar values and that maximize the differences between classes. The features are divided into classes whose boundaries are set where there are relatively big differences in the data values. Natural breaks are data-specific classifications and not useful for comparing multiple maps built from different underlying information. You would use manual interval to define your own classes, to manually add class breaks, and to set class ranges that are appropriate for the data. Alternatively, you can start with one of the standard classifications and make adjustments as needed. And in addition to that, the standard deviation classification method shows you how much a feature's attribute value varies from the mean. The mean and standard deviation are calculated automatically. Class breaks are created with equal value ranges that are proportionate of the standard deviation, usually at intervals of 1, 1/2, 1/3, or 1/4 standard deviations using mean values and the standard deviations from the mean.